Hey, Dr. Elaine, this is my reassessment for Chapter 18. We have this circuit here, and the first question asks to show the potential paths. Since I know that current flows from higher potential to lower potential, and I know that a round trip to the path begins and ends at the same location. I found the three paths to be starting at P0, going around, going up, going around, going down, and then starting at P2, for example, you could come around like this. So those are the three paths. That was part A. For part B, I know that the sum of potential differences across all of the elements are going to be equal to 0. So that's where this comes from. And V1, delta V1, delta V2 are going to be the potential differences across each element. So for path 1, using the loop rule, I found this equation, the 2 EMF minus E1L minus E2L is equal to 0, where E1 is the electric field in the bulb 1, E2 is the electric field in bulb 2, and L is the length of the bulb filament, and EMF is the EMF of the battery. I did that for each path, and from the options given in the book, I found that equations 1, 5, and 6 were represented the valid energy conservation. So for part C, I know that from the current node rule, delta I is going to equal 0, and the relationship between the currents is I1 equals I2 plus I3. So from there, that's the third equation given in the book, and the expression for resistance is given here. And I need to find the specific resistance to be able to solve for this. So the equation for a specific resistance is given here. I'll plug in my values and I find the specific resistance is 5.78 times 10 to the negative 8th ohm meters. I plugged that back in here and got the resistance is 5.89 ohms. So from the loop rule for path 2, the plus 2 EMF minus E2L minus E1L equals 0. I know that bulbs B2 and B3 are identical and connected in parallel. So E2L is equal to E3L and I2 is equal to I3. And I can substitute 2E2 for E1 in the equation, 2 EMF, which is what I did here. And I substituted 1.5 volts for the EMF and 0.008 meters for the length. And I found that the electric field for E2 is going to be 125 volts per meter, and for E1 it's going to be 250 volts per meter. The expression for the current going through bulb 1 is I1 is equal to E1L over R. Substitute 250 volts per meter for E, 0.008 meters for L, and 5.7 ohms for resistance. And I found that the current going through bulb 1 is 0.34 amps, which is also 0.34 coulombs per second. Then to find out to convert coulombs to number of electrons, I just multiplied by 6.25 times 10 to the 18 electrons over 1 coulomb, which is equal to 2.125 times 10 to the 18 electrons per second. And since bulbs B2 and B3 carry equal currents, the current through each of them is equal to half the total current passing through bulb 1. So I substitute 0.339 amps to find the current in bulb 2, which is 0.17 amps, and converting that to electrons per second, I get 1.0625 times 10 to the 18th electrons. So for I1, it's 0.34 amps or 2.125 times 10 to the 18th electrons per second. And bulb 2 is 0.17 amps or 1.0625 times 10 to the 18th electrons per second.